Alright, welcome class. Here's our next video. This one here is all about classifying triangles. It's pretty quick notes, fairly short, and we'll get through it fairly quickly here. So, first thing we need to do is our warm-up. Name the special, or give the special name given to the pair of angles shown by angle 2 and angle 6. Angle 2 and angle 6 are in the same position on L and M respectively, which means that they are corresponding angles. Now we need to find the measure of angle 3, and we do know that one last angle there, I guess, would be 8 if it had a number to it. Angle 3 is in a corresponding position to angle 7. So whatever angle 7 is what angle 3 is. So angle 7, you just need to take the 118 we do have and subtract it from 180. And 180 minus 118 is 62 degrees. So now that we have that 62, we know every angle in this picture. The measure of angle 4 is a corresponding angle to the angle we do have, which basically just means that the measure of angle 4 is 118. So our vocab for today, all the different types of triangles: acute triangle, equiangular triangle, obtuse triangle, right equilateral, isosceles, and scaling. So here's the four angles that are classified by the four triangles that are classified by their angles. It's going to be acute triangles, equiangular triangles, which are also acute triangles because they do have three acute angles, but it's a special case where they're all the same. An obtuse triangle, and then a right triangle. So, first thing we have to classify this triangle. We know all of them are 60, which means they're all the same, and 60 is an acute angle, so this is technically just an equiangular triangle. Now, theoretically, it's also acute, right? But because it is this special type of acute triangle, where they're all the same, it's equiangular. Our next one, we have three angles given to us: 30, 20, and 130. So since we have that 130, that's an obtuse angle, so the whole triangle is obtuse. This one here we need to classify triangle XYZ. XYZ is the entire triangle. Picture here, the whole thing. And we're given two angles, one's 50, one's 40. We're also given this angle down here is the sum of 40 plus 50. So 40 plus 50 is 90. So that is a 90-degree angle, which means it's a right angle, which means this is a right triangle. Now we're looking at the triangles that are classified by their sides. So equilateral, all three sides are the same. Isosceles, at least two congruent sides. So keep in mind, at least two congruent sides means that equilateral triangles are technically isosceles triangles as well. And then a special type, just like acute triangles and equiangular. And then of course scaling triangles with no congruent sides. So we have three triangles we need to classify within this picture. The first one's JMN, which is the entire thing. We don't know much about the triangle aside from just all these little vertices around it. But just kind of looking at it, we're going to make the assumptions based on just appearance. And JN and MN look fairly close to being the same, but they don't look that close to being the same. So that means that for triangle JMN, we're going to say this one is scaling, because that's what it looks like to me. Then for triangle JKO, that's a little triangle at the very leftmost vertex of the whole figure. And that one looks more like a right triangle to me if we were looking at the angles, but we're not. And the only time you'll have a right triangle that's not scaling is if you have an isosceles right triangle. And we don't have that here. KO and KJ definitely do not look to be the same size, which means none of the sides are the same, and this is a scaling triangle. And our last one, triangle OLN. So OLN is right here. It looks pretty equilateral, so we could assume it's equilateral. But I'm going to go ahead and just say that it's probably isosceles at the very least. So this next one here, we want to look at this picture, and again, classify. We're given that WY is 3, and that Y is the midpoint of VX, which means that these two lengths are congruent. So that means we need to take the 8.4 and divide by 2, and that's 4.2. So both of these are 4.2. And we have no equal sides on any of the triangles in here, whether we're looking at just VWY or VWX or WYX. None of them have congruent sides at all. So all three triangles pictured here are scaling. And that's our last question for the day. We did vocab the day we did these notes, so the vocab slides are going to be next. Well, actually, I guess I skipped this problem when I did the notes in class. So let's do this one real fast. My bad. So we're going to find the measures of the sides of the isosceles triangle. Tells us it's isosceles. With base KL. So if KL is the base, then the two sides that are congruent are KM and ML. So we want to find D, and then we're going to plug D back in. So 4D minus 13 equal to 12 minus D. We're going to add D to both sides. So we have 5D minus 13 equal to 12. We're going to add 13 to both sides. 5D is equal to 25. And then we're going to divide by 5. D is 5. So now we can plug it back into either of these two equations and get what the bases are since they are congruent, or not the bases, the legs are since they are congruent. It also wants us to find all of them. It doesn't say which specific sides. So that's easy. 12 minus D for our first one. 12 minus 5 is 7. So that means that KM is 7 and ML is 7. There's 2 out of 3 sides for our triangle. The last one, D plus 6, so 5 plus 6, which is 11. And that means that KL is 11. Now I think we are ready for our exit ticket in the vocab list. Yep, here's our vocab. All right. So, here's the list of vocab if you didn't do that. And here's our exit ticket.